Hello there, Mr. Sutton here, bringing you the IM3 Chapter 4, Quiz 2, Extra Practice Solutions on Advanced Quadratics. To graph this parabola in intercept form, we're going to first find the zeros. So basically set this equal to 0 and figure out what zeros out each of these factors. So we're going to have zeros of 1 for that first factor and -5 for the other factor. And we can graph those right now if we want. So we have the x-intercepts -5 and +1. We just need one more point, and it's going to be the vertex. To find that, we just average the zeros together to get the x value of the vertex. So that's 1 plus -5, or 1 minus 5 over 2. That's -4 over 2, which is -2. So that's the x value of the vertex. And to get the y value, we just plug that back into the original parabola formula. So we have negative, parentheses, -2 minus 1, -2 plus 5. So we've got -3, that's +3. +3 times another 3 gives us 9. So then we have a vertex of -2, 9. And that is going to be, let's see, all the way up here. And then just draw the parabola through your 3 points. To graph this parabola in standard form, we're going to use -b over 2a to find the x value of the vertex. So that's going to be -2 over 2 times an a value of 1. That's going to be 2 over 2, which is just 1. So that's the x value of the vertex. Plugging that back into the original will give us the y value of the vertex. So that's 1 minus 2, which is -1. -1 minus 3 is -4. So we have a vertex of 1, -4. And let me just go ahead and graph that now. That's right there. Now we need 2 more points, one of which will be the y-intercept. The y-intercept is just this constant at the end here. That's the only thing that's left if you plug in 0 for x, which puts you on the y-axis. So we have a y-intercept of 0, -3. That's right there. And we have the axis of symmetry going through the vertex. So you just have to basically flip that y-intercept over that line of reflection to get another point right there, and then draw the parabola through those 3 points. To graph this inequality, let's start by getting the vertex of this parabola. So that's -b over 2a to get the x value, and that's -2 over 2 times the a value, -1. -2 over -2 gives us 1. Plugging that back into the original, that'll give us the y value of the vertex. So we have -1 plus 2 is +1. 1 plus another 2 gives us 3. So that's a vertex of 1, 3. Now let's just double check before we graph that. Do we have open or solid dots? Looking at my inequality, there's no equals, so that means we have open dots and a dashed line for our parabola. So we've got 1, 3, open dot right there. And now the y-intercept for this parabola, that's going to be this +2, this constant, this c value at the end there. So that's a y-intercept of 0, 2, which is right there. And now we have an axis of symmetry going through our vertex. We'll just use that to find a symmetrical point to that y-intercept. So over on the other side here. And then draw a dashed line through those open dots to get your parabola border anyway. But now we need to shade one direction or another. Looking at our inequality, we see y is greater than the parabola. That means we have to shade all the values that are above the parabola. Greater than means shade above, so all this stuff up here, and then we're done. For this real-life problem, the income in hundreds of dollars of a cotton candy cart is given by I equals all this crazy stuff with p's in there, and p is the price of each pound of cotton candy. I mean, who needs a pound of cotton candy? But it's priced by the pound, apparently. We want to know what we should charge per pound in order to maximize our income and what that income will be. Okay, so we're trying to maximize a parabola, basically, a quadratic. So that means we need to find the vertex, and the maximum value itself, the income, will be the y value of the vertex. And what we should charge, that'll be the x value of the vertex. X is easier to find. We can find the x value of a parabola in standard form by using -b over 2a. So I'll write p value of the vertex equals -b over 2a. So that's going to be -9 over 2 times my a value here of -1/2. 2 times -1/2 is going to be -1. Negative 9 over negative 1 is positive 9. So that's $9 that we should charge per pound to maximize our income. Now the actual income is what we're going to get if we plug 9 in for P in this I formula, like so. And now let me just crunch these numbers on the calculator. So plug in all that in the calculator. Let's press enter and see what happens. Because I used this fancy fraction mode for the 1/2, I get a fraction back. If you want to turn that into something that's not a fraction, you can do math, and then second option decimal. So that's 15.5, and that's $15.50 for our income. For this problem, we have 150 feet of fence to make a rectangular rabbit pen. If we use a barn as one of the sides, what are the dimensions of the pen with the largest area? And what is the actual maximum area? All right, so here's a rectangle we're going to draw out. One side of this rabbit pen is a barn, and the other sides we make from 150 feet of fencing. So we're eventually going to have to get a formula for the area, because that's what we're trying to maximize. So to get that, let me express the dimensions of this pen with one variable. I'm going to let this side here be x, because I've got to start somewhere. And let me express all of this in terms of x now. This other side will also have to be x because they're the same length. How about this side down here? Well, I've got 150 feet of fencing. I've used up 2x of it so far. So then 150 minus 2x tells me how much I have left for this last side. So that's going to depend on how much you use for these other two sides. All right, now that I've got all the dimensions expressed with one variable, let me write my formula. Area equals length times width. Length in this case we can write as 150 minus 2x. The width is just the x here. And now to maximize this quadratic, I need to find the vertex. Since this is an intercept form, I'm going to find the vertex by finding the zeros of this function and averaging them together. So we've got a 0 for this first factor here. If you subtract 150 and divide by negative 2, that's going to be 75 for that 0. And then this x over here gives us a 0 of 0. So now if I average those together, that'll give me the x value of the vertex. It'll also give me the ideal width for this barn. So I'm going to write w equals x of the vertex equals 75 plus 0 over 2, averaging those zeros together. So let's see here. That's going to be 37.5, and that's going to be in units of feet, because this is how long the one side of the fence is right here. We also have to find the length. They said find the dimensions, so we have to find them both. To find the length, we do 150 minus 2 times 37.5. So that's basically 150 minus 75, which is 75 feet. And now to find the area, we just have to multiply the length and width together. So that's going to be a length of 75 times a width of 37.5. And now let me go to the calculator to see what that comes out to. Plug in all that in. We end up with 2,812.5, and that is going to be in square feet. That's a whole lot of area for those bunnies.